Alright, last example here, and this one's going to be a square root function, which is kind of an opposite or an inverse function of a quadratic function. So you'll even see that on the graph. Okay, so let's get that here. I'm doing y equals negative square root of x, and if you've never graphed a square root function, then go ahead and make your table. Plug in some numbers for x. See if there are numbers that you can't plug in, especially if we're trying to figure out the domain. Okay, so I'm going to plug in 0, and if I plug 0 in, I get out a 0. If I plug in a 1 for x, I'd get square root of 1, but then make it negative. So that's where this point is coming from. I would plug in a 2, but I don't really want to take the square root of 2 personally, so I'm going to plug in the number 4 next. And the square root of 4 is 2, and then again make it negative. So 4 comma negative 2. So this is actually half of a parabola. I can't plug in negative numbers. Okay, so I can't plug in negatives over here, and then I don't actually end up with anything up here because when we take the square root, we're looking for simply the positive square root. So that's why we only end up with half of the parabola. Okay, now look, I do have some restrictions this time, either for domain and range. Let's see. So for domain, if I'm looking at my x's, if you look over here, there's nothing, right? As opposed to this side, if I look at these x values, there's definitely points. There are points that go with those x values. So I do have a graph over there, but I don't have one over here. So it looks like my graph starts at 0 and is anything bigger than that. So in interval notation, I start at 0 and I go up to infinity. We always put parentheses around infinities. I include the number 0 also with my inequality symbol because I have a point at 0. Okay, range is pretty similar, but it's kind of on the opposite side because I don't have any positive numbers for my range. I do have numbers down here for the range though. So my y values are going to be anything less than or equal to 0. We of course want to include 0 again because we have a point at 0, 0. So in interval notation, that looks like this. You always start from the most negative and go up. So we go from negative infinity up to 0, and we do include the number 0 with a bracket. Okay, now I just want to bring your mind back to the equation. Remember, we can't plug negative numbers into the square root, right? Otherwise we would end up with imaginary answers, which that's not really what we're looking for when we're graphing and when we're really dealing with this in the real world. So that becomes a restriction on my domain. If there are numbers that you can't plug in, then you have a restriction on the domain and you can't, it's not all real numbers anymore. So for this one it was special. We only had numbers that were greater than or equal to 0 that were allowed to plug in. It would be the same if we had a fractional function. Those are called rational functions. We wouldn't ever want to plug in a 0 into a denominator, and so sometimes that will result in a restriction on the domain for a rational function. Okay, so this is all very interesting. These things do really apply in the real world. If you're wondering why the heck would I need to care about this, this is a real practical application in any kind of career that involves equations or math, such as engineering, anything in science. There are restrictions that we have to deal with in the real world that we're working with. Some of those might just be limitations on what something is able to do or what we want it to do. And that is basically exactly what we're studying here with learning about domain and range and what kinds of things will come out of a function when we're looking at it. So good luck with this. Let me know if you have any questions about specific problems that you're working on, but the more you practice it, the better you'll get. So thanks for watching this week's video.